We're on question 5 now of this this work solution, and we're looking at americium, which is not really that important. We don't need to know that it's what americium is. If you would like to know, it's the isotope, it's the radioactive element that is used inside smoke detectors. So what is an isotope? That's the thing that we do need to know. What's an isotope? Well, first of all, that question, what's an isotope, is a pretty bad question, and I hear it a lot of the time. But the word isotope is like the word type. There are many types of elements, so you can, in other words, there's many isotopes of elements of a particular element. So now all the isotopes have the same number of protons, because if it had a different number of protons, it wouldn't be that particular isotope. So all americium atoms have a certain number of protons. Now we're not required to know that number for this question. We just know that they all have the same number. Now if there are 3 up there, and they said one of them is not an isotope of americium, which means the other 2 must be isotopes. And so you just need to find the 2 with the same atomic number. That's the top and the middle one, and so the one in between is not an isotope of americium. It's an isotope of something else, but not americium. So the answer is B, and the reason is different number of protons. Okay, let's have a look what we've got on the next one. Well, we're looking at it's probably going to ask us about half-lives. Yeah, there it is down there. So what's happening is these nuclei are decaying. Now, if you're a little bit rusty on radioactive decay or radioactivity, it essentially something turns into something else. The classic is carbon. An isotope of carbon can turn into an isotope of nitrogen, and it gives off something else. In this case, it gives off something called a beta particle. But that's not. We're not really interested in for the purpose of understanding what decay means. We're not interested in the other thing that's given off. The key point is that something which shouldn't. It should just carbon should just stay as carbon, which we learned from chemistry. But you can't. An atom means indivisible, but it turns out that it's not really the case, that a carbon atom can randomly become a nitrogen atom. So that's what decaying means. And we start off with some americium, and they change into something else. First question is just saying, how many years did it take for americium to decrease from 10,000 to 5,000? Well, it's at 10,000 at the beginning. The time it takes to go to 5,000 is, well, let's just have a look. That's where it's that point there. So at that point, it's got to 5,000. Well, I can see that's going to be down to about there. You can see, because the slightly thicker line to my left, which is making it a bit easier. And we'd have to zoom in to get a more accurate amount. So this is, I should have made these pictures bigger, but never mind. So this halfway line will be the 500, and then that's separated into five squares there in between. So I use my mouse here. Between there and there is separated into 5 squares, so that would presumably be on the first square. So if that represents 100, then 1/5 of 100 would be 20. So the answer is 420. It says, what is the half-life of americium? It's really only testing your understanding of what half-life means. The half-life is how long it takes for the amount of something to reduce to half of that amount. It started off at 1,000. It's decreased to 5,000. So the half-life is also 420. Okay, let's continue. Let's zoom all the way out. Oh, okay, we've got the next row down. Okay, so we're looking at nuclear. Oh, that was question 5. Okay, let me just save